When performing financial calculations, the rate compounding period, the number of periods, and the payment frequency must be the same, all in months, all in years, all in weeks, and so forth. This video segment will go through the process of converting rates to match differing compounding frequencies. In this segment, we will look at two examples to illustrate this. A chart has been prepared that is a roadmap that can be followed to do this. So the key is that all arguments must be the same. If you use a future value function, you have a rate which has to be then for the same time period as what the number of periods. If the rate was quarterly, the number of time periods must be quarterly, and the payment should be, if there is one, must be a quarterly payment. How do we get that handled? Let's look at some examples. We have a roadmap here which will help this. In a previous video, we stayed within one branch of this. We went from monthly PAR to nominal NAR, monthly NAR, to an EAR. And then we went down the other way. We also did this for quarterly. We went from a quarterly PIR to a nominal NAR with quarterly compounding to an EAR and back down. Note that the common denominator between these is the NAR. EAR is strictly an annual measure. It's by definition is annual rate, effective annual rate. It has no it's one compound per year basically. It's annual. And so we're going to use that common denominator to move from one place to another branch over here. Let's look at an example. Say we have an NAR with monthly compounding, 4%, and quarterly deposits. The deposits are $1,500 quarterly. Since the deposits are quarterly, in this example, we will switch to a quarterly rate. So we want to go from a 4% NAR with monthly compounding to a PAR with quarterly compounding. We want to go from right here, the NAR with monthly compounding, and get up and back down to quarterly periodic interest rate, PIR. Some reason today I cannot say PIR. It won't come out. Keep trying. So we start with the NAR of 4% right here in this place on a roadmap. We use the effect function to move up to the EAR, which is 4.074, effect B2, that's this value, and 12 months per year. We're in monthly compounding, we're converting monthly, so we stay with the 12. From the EAR, we can go down, we want quarterly, so we'll go down to an NAR with quarterly compounding, that's this one. Use a nominal function with 4 quarters per year. So we do that here. Nominal B3, which is the EAR, and 4 quarters per year, and we now have our NAR with quarterly compounding. To get to the quarterly PIR, which we use for calculations, we always use PIRs to compute interest. We divide by 4, and it's 1.003%. So then in a future value function, we have 30 years, which we're working in quarters now. We're converting everything to quarters to match our quarterly deposit. So there'll be 120 quarters. Each one has a $1,500 deposit. And so we have B5, which is a quarterly PIR, B7, which is 120 quarters, and B8, which is a quarterly deposit. They all match. We do not have an initial value. It's 0 as in B9. And put that together and the function will tell you that at the end of 30 years you should end up with $345,871. Let's look at a second example. We want to start with NAR with weekly compounding, 4% again, and deposits are made annually. Again, they don't match. So in this case, we're going to convert to an annual rate. So we have an NAR right here with weekly compounding, and we want to get over here to annual. So the first step is to go from NAR with weekly to the EAR. That's B14, which is the 4%, 52 compounds per year. Gives us 4.08. And then the little trick here, to go from EAR to nominal, you only have one compounding period because it's annual. There's one per year. So it's B15.1, which means you get the same value for NAR annual. And the PIR is the NAR annual divided by 1. And that's the same. So when you're in the annual branch here, the EAR, the NAR, and the PIR will be equal. In this case, they're all 4.08%. So essentially, you can use the EAR. You don't have to do these two conversions if you're annual compounding, and only if. So again, if we have a $6,000 a year deposit, upfront 0 for 30 years, put that in this function. B17 is the 4.08%, B17 30 years, payment $6,000, B20 is 0 upfront, and it ends up to be $341,012. Again, we made all three to be the same time period. And this chart can help you visualize that. After you do it a couple times, you won't need the chart, but it helps you work through it the first few times. Thank you.